Okay. Can you hear me? Because I got a notice that the connection is weak. Just want to make sure you hear me. Yes? No? You can? Okay, perfect. We are going to perform the chapter 6 or experiment 6 experiment. Experiment 7. We are going to monitor today to make sure we have some crystals from the last time, because if we don't have crystals, I have to repeat that experiment today. So we have crystals for Wednesday, because if we don't have crystals, we're not going to be able to perform the experiment on Friday. So I have to check that today. Remind me later if I didn't. We have to check the crystals to make sure we have some prismatic crystals for tomorrow. The steam distillation. What is the advantage of steam distillation? When do you use the steam distillation? Under what condition you use the steam distillation? Can I use simple distillation instead of a steam distillation today? Why would I use a steam distillation today? Immiscible substances. Okay, that's one condition. The substance must be immiscible in water because it's a steam. Steam is water. When the substance has boiling point that is very high and it can decompose the compound when it's heating for distillation, then we want to make sure to lower the boiling point. The boiling point is very high, but we're trying to lower the boiling point. We use a steam distillation. So when you use steam distillation, basically, what would be the boiling point of the mixture? Approximate boiling point for mixture? Or any limitation for the boiling point? What would be the boiling point of the mixture? The mixture is going to start boiling at what temperature? The boiling point of the compound could be 225, but we are trying to lower the boiling point. So what would be the new boiling point? What would be the boiling point of the compound when we are doing mixture, when we are doing steam distillation? It happens when the vapor pressure of the liquid changes to or gets equal or reaches the atmospheric pressure. If the atmospheric pressure is 1 atm, then the vapor pressure must be 1 atm or 760 millimeter mercury in order for the liquid to start boiling. When you have mixture of two liquids that they are immiscible, the boiling point is going to be lowered. Why the boiling point is lowered? Contribution of the vapor pressure is going to be linear. So you have two compounds. For immiscible compound, going to add up. You get vapor pressure from water, and you get vapor pressure from your other compound that is immiscible in water. So had only water, pure water. At what temperature the vapor pressure of water would reach to 1 atm or 760 millimeter mercury? That's definition for boiling point of water, right? At what temperature the vapor pressure of water equals atmospheric pressure. In other words, at what temperature water would start boiling? Boiling point for water? What does it mean the boiling point is 100 degrees Celsius? That means at 100 degrees Celsius, vapor pressure of water equals atmospheric pressure. If the atmospheric pressure is 1, then at 100 degrees Celsius, the vapor pressure of water is going to be 760 millimeter mercury or 1 atm. That's just if you have pure water. If you had mixture of compound 1 plus water, some vapor pressure from the other compound also. So your mixture is going to boil at less than 100 degrees Celsius. So regardless of what it is, the contribution from the other compound, as long as it's not 0, is going to be, if it's 0 at 100 degrees Celsius, that means the compound must have like 1000 degrees Celsius boiling point. So the vapor pressure coming from the other compound would be very, very low. So if you get the mixture of two compounds that they are immiscible, vapor pressures is going to add vapor pressure from water, vapor pressure from the other compound. And since the vapor pressure from the other compound is not 0, then vapor pressure is going to reach 760 or 1 atm in less than, at the temperature less than 100 degrees. Less than 100 degrees Celsius is going to protect the compound from decomposition, so it's not going to decompose. Please pay attention to the theory of the experiment. Understand why we are this, how we are doing, why we are using the technique that we are using. Otherwise, it's going to change the cookbook. And cookbook, it's even, it's probably better when you are, at least you're cooking yourself, then you face like some complication and you are going to solve the problem and then you learn by mistakes. But if someone else is presenting, your understanding of theory of the experiment is going to be more essential. So I'm going to, for this, like select like one chapter, like one experiment. I'm going to grade only the theory of the experiment. So if your theory is weak, you're not going to get the grade that you wanted. So do not just, please don't set back, don't be relaxed. It's an online lab. So you have to understand the theory of the experiment and understand what does it actually mean. If you read something and it doesn't make sense, then you would just say, I don't understand this part. Explain it to me. Page 77 in the hard copy. See, the last line is just one page here. It's talking about the theory, and the last page it says, for example, naphthalene is a solid that has boiling point of 218, but is below 100 degrees Celsius. Why is going to below 100? Because the vapor pressure from water, if it was pure substance, it would be equal to atmospheric pressure at 100 degrees Celsius. There is some vapor pressure coming from naphthalene, which is helping the water to boil at less than 100 degrees Celsius. Okay. So, what is the purpose for today's experiment? Why are we doing today experiment 6 today? What are we trying to do? The purpose of experiment? Isolate eugenol from cloves. Okay. Eugenol is a essential oil. You want to isolate that from cloves, which is a natural product. I want to test and make sure my heating apparatus is. So I'm going to set this up for now. Make sure you know the procedure because I need your help for the procedure. What is the next step for me? What do I expect? What do I need to do next? I have my heating apparatus. That's the only thing I have so far. What do I need to do next? Because what should be your next step? If you were standing here instead of me, what would you do next? Okay, I'm waiting for you. Tell me what to do next. Using a boiling flask. The name for this flask is a boiling flask, and it's different from the flask you use for the distillation because you had for distillation you didn't have these two other necks, so this is called a 3-neck boiling flask. So you have your boiling flask, and you're telling me to measure 5 grams of cloves. Okay, gonna measure 5 grams of cloves. Okay, what else? Going to measure 5 grams of cloves. Boiling flask, right? You want me to add the 5 grams of cloves to the boiling flask. What else? Add 50 milliliters of deionized water. Okay. I'm going to remove this for now because I don't want any water to get into the electronics. So I'm going to add the water. Next. Set up the simple distillation. Okay. How should I set up simple distillation? Do you have the page for simple distillation? Do you know how to set up simple distillation? What is missing from the simple distillation? I have part of the equipment. What is missing? Condenser, thank you. So I'm missing a condenser. Condenser, it doesn't attach directly to the boiling flask, so I have to use a greased distillation head. Okay. So I'm using a grease distillation tap. Looking for those two clumps that right here. I have some. Okay. Going to attach condenser. Make sure to use a clamp to protect it for a silk system. I have to protect the condenser using a 3-finger clamp. Next, separate the funnel with to one of the next step. What's the next step? I hope you're not reading the first time. I'm sure you wrote the procedure already. You turned it. What should I do next? I already did the funnel. I already attached the funnel. What's the next step? Distillation head is already in. That's how I connect the condenser to the boiling flask. I have to have a distillation head. The stopper, I did, okay, here is the stopper. I'm closing the neck with the stopper. I add the water to the separator funnel already. Next. Come on, you could do better. You can give me better instructions, faster instructions. Is 14 of you are actually following the procedure at this point, right? Or 15 for a change? What's the next step? What should I do next? I don't want you wait for me to come and perform the experiment and you watch, or you don't watch and then you just watch whenever you have to. It's a live lab, it's a distance learning, it's not a fully online lab, so we have to. Okay, my connection is not prepared, my setup is not ready yet. It's early to heat. I have the heating ready, but my connections, my glassware is not set up yet properly. What is missing from the picture that you have there? Receiving flask. In this case, is going to be, this is called the receiving flask. So we need to use the utility clamp. Great. So we do need a receiving flask. I'm not using the open container here for it because it's hot vapor, hot water that is coming in. I'm not running cold water through the condenser because the temperature of the water, it's, as soon as the room temperature is much lower than the boiling point of water. If I use water circulation, cold water circulation, the oil from the extract is going to freeze up here and not going to move down. I can attach the water hoses and I turn on the water only if I see vapor coming out. That means the condensation is not efficient. Then I can add I can turn on the water. But based on the room temperature now, I think the temperature of the vapor is much higher than room temperature, and the air condenser is going to be good enough. So we have the condenser. If we don't attach to the water circulation, it's acting like an air condenser. So we can use that air condenser for now. If we see vapor coming out, that means I have to lower the temperature or I have to add water circulation. So I'm going to attach the hoses, but I'm not turning on the water for now, unless I really have to do it. And I would know I have to do it if there is a waste or loose of vapor. I have to make sure my distillation apparatus is sealed, and in order to make sure that it's sealed, I greased glass joints. I also use these glue clamps to hold the joints together because as I'm moving around or I'm adding something else, it might separate. And before the solution starts boiling, which I already turned on the heat, so it should start boiling. So I want to make sure that all the joints are secure. When we attach the water comes in from the lower end and exits from the upper end. I'm going to connect the lower end to faucet. I'm not turning I'm turning on the water circulation at this point. Wait the distillation to start. So some vapor has formed already, it's steamed here, but it's not boiling yet. What is the purpose of using the water in the separator funnel? That is not explained in the lab manual. I want you to think and tell me what would be the advantage of, what's the purpose of using the water in the separator funnel? Add additional water if needed. Now, can I just, if I use the regular boiling flask, if I had used this flask, to add additional water? Can I just open it and add water and then continue? I probably could, right? But it's not convenient because in order for me to open the distillation apparatus, I have to make sure my distillation apparatus is cold. There is no vapor because when I open it, I don't want to lose the vapor. I don't want to lose the compound. And then add water and then connect it. So if I do that, I'm going to slow down the process. But if I have the water already in the separator funnel, I could just open the stopcock and start adding, like drop by drop. I could start adding when it's boiling. Actually, I could add one drop at a time. Or when I see is dryness, because you cannot distill to dryness. You should never heat up too much to dry because it can crack the glass. I would open the water, stopcock, and then get the water transferred into the boiling flask. If you didn't have the 3-neck or 2-neck boiling flask, then you had to add all the water at once, or stop, cool down the system, and then add the water and connect it again. Do we have to add boiling chips to this boiling flask at this point? You should never distill without the boiling chips. I started this already, and I cannot continue as soon as I find out I forgot the boiling chips. I can't continue this reaction, the distillation. I turned off the heat. I wait to make sure there is no vapor. Build up. If I open it, the vapor is not, the fume is not going to come out. I open, add the boiling chips, close. If it was boiling harder, it would take longer to cool down. But since it was boiling, it was just hot, it took less time for me to open it. So I cannot open it while it's hot. So I wait until it cools down, make sure there is no vapor in the distillation head. Then I can open and drop the. For this specific experiment, I have a solid compound. The cloves are used. Each of these cloves could act as each piece can act as one boiling chips also. So for this experiment, the boiling chips was not necessary, but the good practice for distillation is you should always have a boiling chips. That's why I added to make sure to emphasize on the importance of using boiling chips. So you must have the boiling chips in there. Okay. Take a screenshot of the setup so you can include that in your file with the pictures, and also have what was set up. You see the boiling and condensation, it already started, so we're just waiting for more vapor to be produced, and the vapor that is coming to condenser, what is going to have? What would be those vapor? What's the nature of the vapor that coming into the condenser? Is it a pure sample? that's coming to the condenser. No response? What would be the sample if it was just a pure sample? It would be vapor of what? So if it's just a pure sample, it would be just water, right? Water vapor coming up, or steam that is coming out. It's not pure sample that is coming to condenser, is the water vapor plus the droplets of the oil, that water as it's boiling from Cloves, and as it's boiling with by the force or by kinetic energy that the steam has here, is going to give some energy, pull up those, because those oil droplets is not going to be boiling to come to the condenser, but is actually being pulled by the vapor, or is being forced or extracted by the vapor and coming into the condenser. So the vapor, if it makes it to the condenser, is going to be mixture of the water plus water vapor plus droplets of the oil. If you're wondering what I'm trying to do, I like the boil to be aligned with the distillation head, and if I have like fractionating column, I want it to be like aligned, not with an angle tilted to one side. Somehow it makes the vapor travel easier or better um, when I have it all straightened up. Okay, the droplets are coming in now into the receiving flask. What do you have in there? Why is cloudy? What I'm collecting here, do you see it's cloudy, or you need the background there to see cloud? It's cloudy. So it takes the part. It's cloudy. Why is it cloudy? The mixture of two immiscible compounds makes it cloudy. Okay. It's cloudy because of the immiscible compound. Of the distillate should we collect? How much should we collect here in the flask? How would I know it's 25 milliliters? How would I know this is 25? The best way to know if it's 25, I take a similar size of the flask. If that is 100 milliliter, I take 100 milliliter flask and I add 25 milliliters of water. So 25 milliliters going to be this much. It's not exact, so we don't have to use a pipette or burette for milliliters. Approximately 25 milliliters. So when I have this much of the liquid, then I can add more water and distill more. So you can leave this, take a donut, keep this in an inside donut so it doesn't roll. It's on the, just to hold it next to it when I'm trying to stop the distillation or approximate how much. The other technique have been to put the water first, 25 milliliter water, and use the marker to mark the glass. And when it reaches that line, is 25 milliliters. So either one. Okay. Do you have any questions at this point? Have any questions for me? No questions? Okay. There's a sample from last class that I said we are going to see how, if the crystals have formed or not. Remember, I placed the sample in the cabinet last time. Last lab, so we will come back and check to make sure we have crystals. And for Wednesday, so I don't have to be worried about it today. So I'm going to just continue for more crystals to form until Wednesday that we can take it and use it. I actually prepared 2 samples and I have both samples here. On Wednesday, I'm going to look to see which one I get more right at the sample, which one gives me more prismatic. I will use that for experiment, to continue with experiment 7. We have crystals. Because if we don't have crystals, we cannot do the experiment, or we could have not done the experiment. So yes, we have crystals. What do I need to prepare while we are waiting for distillation to finish? In terms of the equipment and chemicals, what do I need to prepare? What is the next step? What do I need to prepare? Next steps, equipment or chemicals. What to prepare? But in order to do extraction, I have to prepare my extraction apparatus. So set up extraction. What do I need for extraction? In terms of the equipment, the glasswares, what do I need to prepare? Get ready. What equipment is used for extraction? Pipette. For extraction, what else do we need? Extraction was experiment 3 or 4. Vacuum filter for extraction. I'm not sure. We don't always use vacuum filtration for extraction. Sometimes we do, but for this experiment, we don't need the vacuum filtration. Separator funnel. What else? We need the separator funnel. We have to have a container. Our separator funnel must be, the cap must be greased. The stopper, the glass stopper must be greased. And can you, successive extraction means? Successive extraction. For better efficiency, repeated extraction for better efficiency. And what are the 3 steps for successive extractions that is important to do? You're adding a solvent, what should you do? To shake it, very good. Vent it to release the pressure. And last one. Separate, very good. I expect everybody to participate in the discussions. And if it does continue, I don't get participation from everyone, I'm going to have to stop the recording of the labs, because I could always do experiment on my own. So I don't have to have a recorded live sections. That way, the live lecture, so there would be live performance. So there would be no records for you to go back and watch it. And that's one. The other would be to give half of the lab report grade to participation. So I don't have to use any of those techniques if participation is from your side is going to be like more participation. So participation is welcomed by you guys. But if not, there would be no recording and no reference for you guys. Because attending the lab is different from logging into computer and clicking on join and then leaving for long breaks, right? Okay. So shaking, venting, and separating, those are the three of the steps that you have to use for consecutive extraction. Do you know why I'm transferring the sample into a cylinder periodically? I transfer the sample from the receiving flask into graduate cylinder periodically. Any reason for that? You can't see. Okay. You want to keep track of the solvent. That's one. Keep track of the volume, how much we are collecting. And the second reason for that is sometimes the mixture, it foams out. And when it foams out, the whole mixture of the cloves is going to go into the condenser and then it gets mixed. So we're at least, if it happens at this point of the experiment right now, if that happens, because it's something that we cannot control. Like if it foams out, it's something went wrong and it foam out. Since it happens for this type of experiment, so we collect these periodically. So if it foams out right now, I at least have like 35 milliliters of the of distillate. I can continue with what I have collected already. That's why we collect these periodically, and when I get to like 40, I can start the extraction already. So the extraction is going to be with 10 milliliters or 15. It says on the procedure I'm changing to 10 milliliters. 10 milliliters of methylene chloride. For the if I use 40 milliliters of this, I can use 10 milliliter or 50 milliliter of the distillate. Then I can use 15 milliliters of the methylene chloride, or dichloromethane is the same thing. Yes, to ensure that it does not contaminate. Very good. So there are two purposes. One, to keep track of volume, and second, it's to ensure that there is no contamination. Very good. I have 40 ml of the sample. I'm going to continue distillation, but at the same time, I'm going to start my extraction. If there is anything collected, I can add to my second extraction. So I'm going to bring the 10 of methylene, or bring the 45. Add the distillate to the separator funnel. If you don't feel comfortable, you could use funnel, glass funnel to transfer, or can transfer without spilling the cap. Is the video working? Am I blocking you, or the video is not working? The video is not working. Let me disconnect and connect. Hopefully, maybe the Wi-Fi is not good. The Wi-Fi. Better? Is the video working? Okay, perfect. Perfect. Okay. So we transfer the distillate into, I already have 15 milliliters. So because I have 50 milliliters of the distillate, I'm going to turn off the heat here for distillation. Turn it off. I prefer to unplug electronics as soon as I'm not using. I'm going to lower the heating mantle, because by lowering the heating mantle, I actually stop the heat. If it's at times the heating mantle still is hot, it's going to continue heat. So I have some collections here. I'm going to take it and add to what I have from before. That's going to add to more than even 50 milliliters. I'm starting with the 50 milliliters. Okay. So I have 50 milliliters of the extract in the separator funnel. I have the glass stopper already greased. If you remember from extraction experiment, I explained about the stopper being greased. If not, you're not going to be able to stop the leakage. The sample is not good. The system is not going to be sealed. And when you try to mix it or vent it, especially if it's not greased, this is not greased, the liquid is going to come out, and then you spill on your hand and you lose the sample. That's probably more important while you're in the lab, not to lose the sample, and then your safety. So it has to be greased. Make sure that is going to seal the system. You're going to add the solvent, shake it, vent it to release the pressure, and then put it back in the upright position. Make sure before you're putting it back, the stop hook is closed. You put it back in the upright position, place it on the iron ring, let the separation to take place. Kind of waiting to get these a little bit cooled off also because it's hot. So I add the methylene chloride. Is going to be, so I'm adding 15 milliliters of the methylene chloride first time. 15 milliliters, 1.5. I have to shake it and vent it. I don't know, you can hear the fizzing sound as the gas is being released. It was too much of the pressure that even some of the liquid left. Okay. Then we are going to place it back in the iron ring to make sure the two layers are separated. We crack the bottom layer and continue the extraction. So can you tell me what do you have at the bottom layer now? What's the composition of the bottom layer? Bottom layer, the methylene chloride is immiscible with water, so it forms two layers, but there is no guarantee that always the bottom layer is water. As a matter of fact, today, for this experiment, the bottom layer is not the aqueous solution. So if you look at the density, what's density for water? Density for water and density for methylene chloride. Write them both, please. Use the chat and write the density for water, density for methylene chloride or dichloromethane. Water is 1 gram per milliliter and methylene chloride is? What about methylene chloride? 1.37. So which one is heavier? Which one has higher density? Methylene chloride has higher density, so the bottom layer is going to be methylene chloride. Okay, my question, what is the composition for the bottom layer? Is it pure methylene chloride? Is that what we have, the bottom layer? No. So it's not pure methylene chloride. What is mixed with methylene chloride? What is mixed with the methylene chloride? What's next step? If you don't know what's mixed with the methylene chloride, really there is no next step. Anybody in class? Does anybody know what is mixed with the methylene chloride? Because it's not pure methylene chloride. We don't want to add methylene chloride and receive methylene chloride. That's like filtering water, right? You put water and then you get water. Why would you filter water? Why would you filter like a DI water, pure water? What is mixed with methylene chloride? Impurities? Not just impurities. We don't like the impurities, but we like something that is mixed with the methylene chloride at this point. Dichloromethane and methylene chloride is the same thing. It's the same exact composition, same compound, but it has two different names. You can take a screenshot at this step. I'm adding calcium chloride. I like to have an answer for the first, the clove oil, okay, which is called Eugenol, right? So oil from the clove that was steam distilled when we get in the receiving flask is mixed with water, but we want to bring it, if we boil the water, we try to boil the water and stay with the oil only, because the steam of water is so powerful, high temperature, it can take the oil also to vapor phase. But we mix it with organic layer, which is methylene chloride. We bring into the methylene chloride by extraction, and we get to extract it into methylene chloride layer, and then we evaporate the methylene chloride in order for us to get the oil by itself. It was cloudy before. I don't know you noticed or not, because I asked you to take the screenshot so you could look at the screenshot now. It was cloudy. When I add the reason it was cloudy because it had water mixed with the methylene chloride layer. To remove the water, I added the anhydrous agent of calcium chloride, because someone said to dry it out with the calcium chloride with anhydrous agent. So we are going to now the question of how much of calcium chloride should be added until the liquid is clear, is not cloudy, and also this calcium chloride is moving around. It did not clumps together. I need another beaker to pre-weigh. So let me go get the beaker to pre-weigh. Okay. 30.367 or take a screenshot. .367. That's the beaker. Mass of the beaker by itself. So what do we have in the beaker now? I transfer only the top layer without getting any of the solid in. The solid is just there to remove the water. We don't want to get any of the solid into beaker, the final product. Is this the oil? No. What is it then? If it's not oil, what is it? What do we have in the beaker if it's not just oil? Decanted solvent, is it pure sample? Is this a pure sample? What's the name of the solvent? Is this a pure sample? What is in there? What's in the beaker? Okay, dichloromethane solvent, just the solvent. Is it just the solvent? What do we have in there? Is the solvent plus the oil? So when we heat it up, we evaporate solvent, the methylene chloride should be evaporated, and we end up with just the pure oil left over. There are two tests for this reaction. One is permanganate test. Permanganate, it tests for carbon-carbon double bond. So if we have CC double bond in this reaction mixture, and we have OH that is coming attached to the benzene ring, that means phenol, then we can say that we have the product of eugenol. We have extracted eugenol. Now, what does permanganate do? Permanganate is going to react with the CC double bond, and permanganate is going to oxidize the CC double bond. Permanganate is a purple color solution. When it does oxidize, it changes to like a brown precipitate. The color of the permanganate is going to disappear. So if this solution can reduce the permanganate, that means it has CC double bond. You see the color change from purple to brown? That is a positive test for the Bayer's test or permanganate test. That's one test. Take a screenshot of this. One test. That was the permanganate plus the sample. And the second test is your sample plus ferric chloride. Ferric chloride has like a light yellow color. If it changes to dark color, dark like orange color or red color or green color, any dark color, that means that your compound has OH from phenol functional group. So ferric chloride is test for phenol. So it should change like a darker yellow color. It's getting darker now, but we're gonna have to wait for dark color to appear. Okay. In this compound, this mixture, you see the oil is miscible with the methylene chloride. If we had water with oil, both of them would come out. But if we have oil with methylene chloride, because it's miscible, the one with the lower boiling point is going to boil first, and then the one with the higher boiling point. So the lower boiling point, which is the methylene chloride, is going to stop. It's going to boil out first. When it's finished, it will stop boiling until the temperature reaches the boiling point of the second compound. Just before this compound starts boiling, we have to stop the heat because we don't want the second compound to boil. We only want to boil off the methylene chloride. We want to remove the solvent and end up with only oil at the like we don't get too much of the product. If you get too much of product from 5 grams of cloves, that means they are charging too much for those essential oils. See, the essential oils are so expensive because You start with like 5 grams and you end up with like 1 gram or less of the oil, or so we don't get too much of the product. So definitely that's not our product yet. It's going to, this is mainly methylene chloride with some eugenol in there. And one of the reasons that this reaction is slow, because the solution that I'm using now is a very low concentration. If I get high concentration and then I add the ferric chloride or the other reaction, the reaction would be much faster, because you are dealing then with the compound, not just solvent. Do you have any questions? I'm waiting for the methylene chloride to disappear, but I need to plug in the laptop for now charger before it's turned off. Okay. So, do you see green color there, or you need the background? Let me use the background. A green color, a shade of a green color appeared, and that is positive for phenol. A green color. I don't know if it would be better on the white background or the black background. It's better with the white background, looks like it. You see that? Okay, you can take a screenshot for the color, and the green color, it means positive test for phenol. Okay. This one was a positive test for permanganate. And with permanganate, it gives positive test. Okay. To take the distillation apparatus apart, you should start from cold to hot. So you first take 1 glass piece at a time, you put it back in where it belongs before you take another piece of glass, because you don't want to have too many pieces of glass at your station to minimize the lab breakage. So you detach the condenser next. Turn off the water first. Separate, so make sure the water drains out. It looks like water that it was running, it was too hot by the time it was reaching the top, because it did melt the plastic here. Oh. Okay. Separate the thermometer, twist and pull, so you don't break the thermometer. Distillation head. And separator funnel. Okay. Questions? Any questions for me? To go back and check on the methylene chloride. Still is boiling. Has not stopped boiling. The phenol test, okay. Got it? It's the phenol test. Went from yellow color to green color. Okay. This one is more obvious of green because it's more concentrated now. Okay. Okay. We're waiting for the mixture to stop boiling. As soon as it stops boiling, I can stop the heat. Okay, what should I move up, Caitlin? That's it. That much of the product. We're going to measure the mass. We get the exact mass for the product. It is oily, and finally it smells better because before it was mixed with the methylene chloride. You can take another screenshot. .800, you can record that. 3.30.800. We are done with the experiment. I'm going to stop the recording. I want to still talk about the experiment and how we are going to work and how we have been working, and I don't want to, I don't want to water down any course competencies. I want to make sure you get the maximum out of these distance lab learning. So let me stop the recording. I call attendance, and then we also have more to talk about this experiment. Do you have any questions about this experiment before I stop the recording? Any questions about this experiment? No? Okay.